All right, welcome everybody. I don't know. I get to this moment every single month, and I'm like, I don't know. Like, I don't have a thing to say. I don't have like. I was gonna say like the 10th annual, but it's like the monthly thing. If you guys appreciate it. Loki.
Sure.
Share this window, so I think it's easier to follow along. All right. So if there's nothing or something missing, throw it on the agenda. But we'll talk about Observability Con, Loki 2.4. Since Roger's here, and I've been chatting with him a bit about some work he was doing on the tailing in Promtail. I figure we should talk about that. I want to do a demo and talk a little bit about the work that is going on for making Loki easier to run. And then Kavi is going to do a demo on a project turned into something that we'd like to see finished up so that folks can use log CLI against text files on their local machines, like a super fancy grep. Yeah, like I said, feel free to add stuff if you'd like to talk about other things. Hopefully everybody's seen Observability Con. There's a talk on Loki Wednesday, November 10th. I guess we have Pacific time and UTC for options, so put it in your calendar, check it out. There will be a live Q&A, so that's the incentive to come watch it live. If you can't make it live, we're going to make the recordings available, I believe, the same day for this conference, which is nice. But Trevor, Owen, and Ivana are going to go through what's new, how we've basically been working a lot on the usability and flexibility for Loki for a lot of common use cases. But I'm not going to give away any more, even though that's, you have to come watch it. In the same time frame, we are targeting the next Loki release to be at the same, basically right around Observability Con, which is going to wrap up, most of the features we're talking about in what will most likely be non-beta format. So things you've already heard us talk about, recording rules. Danny's talked about this before. There's an implementation out. He has been improving that implementation to take advantage very cleverly of a lot of code already from Prometheus for having a write ahead log and replaying that log to give a lot more durability to recording rules. So we're pretty excited about this. We are running, actually, I think that it makes itself available in all of our hosted clusters probably by the end of this week. So if you want to play around with Loki recording rules, I guess I'll just shill our hosted offering real quick. But it's a good way to go see. And if you make a new account, I believe you end up with the new Grafana alerting experience too. So that has easier ways to create recording rules through the UI, so you can play around with logs to metrics. I recommend it.
Yeah, we're using it now to power a lot of stuff in Grafana Cloud too. Log generated metrics that we use, even then some that we then redistribute out to clients. We've been happy with it, running it for a while on some of our internal clusters. I know that we are ironing out a couple like small bug fixes and stuff before we get it in the release, but it's looking very good.
Yeah, definitely. I think the first sort of fun use case for us is we log a lot of statistics around Loki queries in Loki's logs, and we write some recording rules to basically extract some per customer query latency, query throughput, query metrics. We could do this with traditional metrics, but the nature of our sort of distributed infrastructure means you typically get these metrics scraped from, depending on the size of the cluster, tens or hundreds of pods. So you get a lot of cardinality from the environment. So I'm not sure that I'm going to say this is the best way to solve all of your problems, but what's interesting is you end up, if you do it through Loki, so if you have access to these metrics through logs and you write a recording rule, you create one series per customer and not potentially hundreds of series per customer. So it has a nice cardinality reduction on generally a dimension you probably aren't interested in, which is what the performance per component within the cluster is. We're just looking at the customer's performance as a whole. So that's been fun.
Yeah.
Out of order, similarly, Owen, I'll just kick this over to you since this has been your championed effort.
Was super happy to finally have like recording rules like round tripping in all of our environments, and like this is something that we've talked about for, I don't know, probably over a year at this point. And to like finally kind of see it all working and hooked up as we expected was a real treat. But anyways, out of order, we've been running this now for, goodness, I don't know, a few months, maybe. Does that sound right, Ed?
I would say so, yes.
And yeah, things have, knock on wood, been going pretty well. So we are going to be releasing this in 2.4, and moreover, we're going to make it the default mode of operation. So this is both kind of coinciding, out of order being a new supported format, but also with like we are increasingly pushing towards having more sensible defaults in Loki. As kind of a lot of our effort is and will continue to go into making Loki easier to use. And this is kind of an example of that. There are a lot of edge cases and weirdness around different agents or deployment topologies that can cause out of order problems. So we're going to go ahead and make this the default mode of operation because there's not really a reason not to from our perspective. Yeah, so super happy about that. Again, another thing we've been talking about for a really long time. And seeing it come to fruition has been great. And I'll kick it back to you, Ed, for the single binary.
Yeah, I was going to put a picture in here of like, we asked on the issues of, oh, actually that was both of these. At some point I'm going to circle back around to the issue that we opened on what people wanted in 2021 for Loki, because I actually think we did a number of things. I mean, there's a lot of requests on the list, so we didn't do all of them, but some of the really commonly requested ones, some certainly out of order logs. And then this one, scalable, simple deployment. We've been trying to figure out the right naming strategy for this. So I'm going to talk a little bit more about this in a couple seconds, but the general idea is how can you run Loki both easier outside of Kubernetes? This gets asked a lot. And even, in Kubernetes, depending on how you're deploying a model that's basically non-microservices, but still supports horizontal scaling, parallelism on queries, high availability, and a lot of the features you get out of microservices with reduced complexity. So we're doing this by kind of opinionating the stack a bit, and I'll talk about the trade-offs in a minute, but that's going to be something that will be a big kind of feature of ObservabilityCon, and if we can get it done in time, which I think we can. But, oh, Roger, I don't mean to put you on the spot here. I didn't know if you actually wanted to talk about this, but
yeah, I can talk about it. So we have a user in our Loki environment that produces, they write a lot of logs, like ridiculously high volumes. And like they were running it first in like a cube, running as a daemon set on a per node basis with Promtail. But based on the Docker, like the cube environment, they had limited disk size, so it rotated the log too fast. So now they moved to like storing the logs on an EFS volume, and then we have Promtail reading from EFS. But what we noticed was that they were still, the problem they had was like they get gaps, because either it would rotate the log too fast, we would miss an entire log file, or with this NFS scenario, we would still lose log files. We would have gaps in the log where it would have Promtail kind of missed the last section of the log. And what I found was that there's a risk since when they rotate the log, they flush the disk, the file cache, and then they rename the file. And since the flushing of the data needs to traverse the network, it splits that up into smaller chunks. And it seems like Promptail is able to reach end of file multiple times before all of that cache has been flushed to disk, causing Promptail to like close the file too early before everything has flushed. So I've made a change to the underlying tail package that we use, so that when it detects that the file is deleted or renamed, it will keep the file open until, like, it will wait until there's been no more changes for a certain time period before it actually closes the file, instead of just running it one more time.
I wrote the code that you're in, so I empathize with the problems that you're probably facing. Well, I should say that we took this library and I added the code that does the one last read attempt.
Yeah.
And dare I say this in a recorded public session, I'm a bit amazed that it's worked as well as it has, to be honest, because it's the going back, like when this is a story time with Ed, guys, because we got a short call today. So one of the first things that I worked on the Loki project when I wasn't I was new to Go and new to a lot of stuff was this. And we had a number of problems with Promptail not following and catching all of the logs. I looked at a number of different ways. So the tailing implementation supports file watches and notifications on changes, and it also does polling. I wish I could remember at this point who it was that did a really, really good talk at FOSDEM about I can't even remember the project now. My brain is I'll find it and put it in the notes because it's worth watching on the different ways to tail a file and like different ways to try to basically do the best job you can. And I looked at how other systems do it, like FileBeat. FileBeat polls, but FileBeat had a distinct advantage that they could poll and send things because at the time Elastic supports out of order, but Promptail doesn't, or Loki did not. So we couldn't leave a thread open on the old file handle. So that's something we could actually talk about now as a different option that we have available to us now, which is having, say, a thread per file, so that because that's the way they handle it, was a timeout at the end that said, if you don't get any updates on this file after a certain amount of time, consider it closed and stop tailing it. Yeah. Actually, speaking out loud is the first that I really thought about this, to be honest, Roger. I would have given you some pointers earlier. So we went with this approach of like, when you get to a notification that the file has changed, the file name has changed, or basically when we do a stat on the file and the file handle we get back isn't the same as the one we have, we know something has changed. It does one last attempt to read the file and the contents to the end of the file before moving to the new one, which actually works really well, aside from the scenario you described where you might be trickling some data in over a network connection. So what you're doing sounds like a good solution to me, right? Like I didn't see anybody else solve this differently other than have some dwell time that you wait to say, okay, I'm really done with this file. The other problem that you faced in the first place is one that I'm also very familiar with too, which is probably more common than people might realize if they're using default Docker or even CRD or CRI configs, where Kubernetes will say the file can be 10 megabytes and it will roll it. You can actually fill a 10 megabyte file pretty quick if you log enough. And the way that last read works, if anything is interrupting sending to Loki and Loki holds that file handle, if you can fill an entire another file before the read on the previous file finishes, you can miss an entire file. So I've actually seen that happen before too. Some of our ingress controllers could log at many megabytes a second, it seems. Well, not in a single file, but the problem is interesting. The solutions you're describing are interesting too. I'm not sure if any other people have come across this, but so yeah, I think we can push kind of through the idea of tailing it. I'm a bit curious now if it might make sense to actually use separate threaded tailors now that out of order is that might allow you to even go back to that first use case where we just keep multiple file handles open and we don't have to I will say though that while that library works really well, it's like not necessarily the most tested in that code. It's like we forked it because the library was unsupported, and so we've made some changes. But yeah, I'm happy to work with you to try to see what we can do to improve this, because it is You're not the only one, I'm sure. The network use case, I would say that's some pretty good sleuthing there to figure out what was happening, because I generally just sort of tell people don't use NFS, but I mean, how can you escape it, right? So that's kind of a cop out.
I'm thinking like, even if you don't use, like, even if it's just like a persistent volume that you mount, like, it's still, I guess it's still a network connection for the.
Yeah, I know. I always tend to forget that too, that most persistent volumes are just NFS mounted. I mean, how else would it work, right?
Yeah.
Yeah, I would like to see us improve this. And I'm curious now how easy it would be to do the out of order was the original limitation as to why it was solved this way. But now that we can work around that, maybe we can. What do you think, Owen?
Yeah, because the negative, like the only flaw that still exists is like, we can't set the timeout too high, because if the timeout is too high and we're waiting for new reads, it might, like, they might rotate the log before.
True, right? You run into that
waiting,
that would be a reason why keeping separate threads on the files would allow you to just move on to the next file and start reading it while you wait some amount of time. Interesting. That actually could improve that quite a bit. I will say, if anybody has the second thing that I worked on it was the Loki canary. Or one of the first sort of things, and it was to answer this question of, when I was playing around in this world, it was like, how good is Loki at actually capturing logs and storing them? So we created the canary, and the answer is really good, honestly. So we have canaries on all of our nodes. We have more than 1,000 of them running now, all onto this ops cluster. They generate millions and millions of logs a day, and I won't tell you that the answer is 0, but we're in the 5 or 6 nines of generally like log traffic. And the ones that miss, I could usually explain, like, it's not Loki's fault, like. So the good news is Promtail does work really well, and even on these high volume cases, we do see this. But it is, I do sometimes chuckle a bit when you sent me that link to that PR and I went looking at that code again. It was like trip down memory lane that I tried to forget. Thanks, Roger. Appreciate it.
Thank you.
Was that for the rest of you all? Story time, was that good? Should we do that as like a regular installment of?
Yeah. I'm just hoping that Ed's going to be the one doing that and not me, right? Like,
that was fantastic.
Thanks, Jordan. Appreciate that. I made a PowerPoint presentation for y'all. It's really, really simple, but I'm gonna do a quick sort of run through, relatively quick, because you guys just listened to me talk for a while, and I have a demo that will hopefully work. But the single binary of Loki has, in my opinion, been one of the best things that it offers in terms of making it very easy to just run the thing. The original Helm install, before we had a distributed Helm chart, just installs it. It's easy to set up, easy to get going. I run it locally on Raspberry Pis, and actually it's, how I tend to do development, just running this binary, and I can hook a debugger to it. It's great. But it has a couple big limitations currently, which is obviously it's not highly available. So if you are running a single binary, while you can easily put hundreds of gigabytes of logs a day into it, if you want to upgrade or something, you have to restart it. That's downtime. And the query performance has never been very good because there's no query front end. So it's just a single threaded query. So you tell it to query something and it will just go fetch all the chunks sequentially and process them as fast as it can. But, that's typically in the hundreds of megabytes a second. So not super fast. So we kind of set out to say, okay, what can we do to make the single binary more scalable? So it's a big jump to go from the single binary to a full microservices install. And outside of Kubernetes, this is just an effort in configuration. I don't know. I won't say the word nightmare, but it's a challenge, right? Like, to try to set up all of the moving parts of Loki specifically if your scale isn't that huge and you just want the features of HA. So what we're doing is making a single binary easier to run, and adding in, so this isn't the best next slide, but basically what the new version of our single binary will do is include the query front end to allow parallelization of queries, and has some additional intelligence for how to communicate with itself. So, the next evolution, if you start with just one, this is the story I want to tell, is you start with one Loki. If you want HA or some slightly better query performance, you add 2 more. The minimum required for actual HA will be 3 because the way our replication factor code works. So with 3, you can support a single node down. And because you'll be adding more cores for both reads and writes, this would allow some more throughput on both reads and writes. But then we're going to take it one step farther, which is adding some new targets called read and write. And so instead of going right into a microservices mode where you'd have to start looking at distributors and queries and ingesters, we're keeping some of those components bundled together so that you have just 2 paths for scaling now. So you can take what was your 3 single binaries and then run them with a target flag of, write and read. You still want 3 for writes for high availability, but you can add kind of as many read paths as you want. And this now lets you scale the read and write path separately, gives you some different stability around the read and write path. So, your read path nodes can crash and it won't affect your write path, or they can be taken down or done or scaled separately, etc. And you can add a bunch more of them. So they do horizontally scale. And you can go down this road to get to, hundreds or thousands of gigabytes, terabytes a day of ingest, and also to get the higher levels of query performance. And then also you still have the option of microservices if you want to get to the road of having sort of the most flexibility and capability over Loki. So microservices have some advantages still. It has a better caching layer. The caching that we're doing, at least in the first version of this, more easily scalable, simple deployment, is really naive, whereas it's not centralized. So there's some redundancy there. So microservices give you centralized caches, even more components. It gives you a little bit better observability because each component can be monitored for logs and metrics separately. We're working on this in this, modified or improved single binary, but when you run the distributor and the ingester and these things in the same process, like their logs are and metrics are the same. So you can't, for example, see the processor time of how long it took in the distributor versus the ingester because the metric that outputs that is the same. So anyway, the microservices approach will always be available. If you're in Kubernetes, it's generally a lot easier to work around. But the idea that this would cover most everybody's use cases where you can have this easier to run, scalable, simple binary. So in practice, it looks a little bit like this. Now, this is Kubernetes just because it's actually easier for us to deploy and do things the way we're set up to operate, but there's no reason that it has to be. We have a couple gateways that sit in front of that. So that's basically just doing some authentication for us, and does some routing to these nodes. The read and write path. So there's a thing in there you call it singleton. Just ignore that guy for now. We're going to try to make that go away. But so you have these separate read and write paths. We've played around with these 3 write path ingesters, and we're able to do 50 megabytes a second into those, which is we're kind of shooting for that terabyte or terabyte and a half a day. So you don't need a huge amount of write path to be able to support a pretty good volume. Let's see if it's 7 days is a long time. Let's do 24 hours just to play around with. So Karen, your question was, is this going to be production ready? Yep, definitely. There's nothing fundamentally that we're changing around how Loki works. It's just sort of how we bundle it and ship it out. So this query might look a bit silly because it is. This is specifically a query that we use to beat up on Loki a little bit. Basically tell it to look for a word and then tell it to not find the same word, which forces it to read every log line and return a query error, which is which is what you want. Let me do a shorter time period. I suspect that's a data source timeout. But the point that I'm trying to prove here, if I can get it to work, is how the parallelization and how that would work for making it easy to add more query processing. So yeah, I guess that was, when did that run? Yeah, that was the same query. So the query finished, but the data source timed out. So, okay. So that was 20 gigs that we scanned. Let's see. And with those 3 queryers, took 20 gigs, 600 megabytes a second. That honestly feels a bit low to me, but let's make a bunch more of these.
Ooh.
It's going to take a minute because we might have to spin up nodes and attach disks to them, but I'll just stall for time and see if anybody has
pod management policy right there. They're all coming up in parallel.
Yeah. So Kubernetes tip of the day, if you work with stateful sets, make sure you always set your pod management policy to parallel, or else these would start one at a time. Ask us why we know this, or anybody that's experienced this, like especially when you're adding things like ingesters that tend to be a bit slower to start. If you're need to get out of scaling trouble, make sure you always have pod management policy set to parallel, and then you can add as many as you want at once. Quite likely our node autoscaler has to add these nodes so that they can start up. My second tip of the day is that this secure shell extension for Chrome is awesome. So you can run a shell in your browser. It's great for presentations.
Interesting.
So while we're stalling for time here, anybody have any thoughts or questions?
Yeah. How's K9s? I'm one of the holdouts on the Loki team that doesn't use it.
No.
And so Ed usually teases me about that. No, I don't have anything against it. I just I haven't learned it.
I mean, it's pretty easy, Yeah. I just ran it and it did this.
Yeah. To get on that.
We're getting there here. All right. So now we got 20 of these. Watch me eat my words here. It'll be the same speed. But so what's actually inside of these, and the thing that I worked on most recently was Loki has a thing called a query scheduler as long as the query front end. So what we're working on is minimizing the amount of sort of DNS configuration that you need to do to run Loki. So having the query schedulers are now embedded into the read pods. They use the ring to allow the pods to discover and communicate to each other. And in theory now, this 12-hour 20 gig query should be a lot faster. Look at that, 6.5 gigs a second. We did it.
Woo!
Right, so that ran in a couple seconds. I should be able to push it out to a longer range now. I think the data source proxy timeout is 30 seconds. That was the query error.
Point being though, right?
76 gigs. So now it's just that easy to scale your Loki cluster. So that's 12 gigs a second, 76 gigabytes. Should we keep going? What happens next?
This is not going to be as fast. You're going to run into your parallelism limits at some point, and it's going to just sit in queue, and it's going to actually hurt you.
Yeah. So yeah, the way Loki's horizontal throughput scales is limited, so that we don't have,
we can calculate the what the highest throughput duration should be.
198 gigabytes.
What do you have?
10 gigs a second.
Do you know the split in the parallelism factor?
Split's 30 minutes. The parallelism is 128. I think.
All right.
I don't have. I don't have an override set up for this, so it's got to reload the pod.
Do 4 hours. I think it should be your longest. I think that's the block of work that your configs let you run in parallel.
I don't think I have enough queryers for this, though, to be honest.
Oh goodness. You don't probably.
Oh.
20 queries, 20 times like 6, right?
Not even that many cores on these machines. Bad neighbors in our dev environment here.
Okay.
Oh, this is gonna roll them out one. Oh no, it won't, because it's the.
I was just saying you should run it for 4 hours. You could see with your current deployment, like what you get to, not how wide can I scale it out and then test it.
Why did that not work? Because I just, yeah.
I think it's L space name. What?
Just rolling them out a little faster. Just kill them all at once. It works with or without the space. That part, at least, I've.
Cool. I didn't know that.
This is just a quick lesson in the probably 2 most important configs that you need for query parallelism too. I'm probably going to break something here. I mean, there is a limit to how much we can do on these machines because they're without sort of making that more than 20 nodes. This feels slower now. Anyway. So the couple things I would point out about this, should have quit while I was ahead, but there are some trade-offs that we're making. I was mentioning to like make it easier to run, which have to do with caching. And I would say though the performance is still really good. So we were shooting for, I broke it. Got greedy. We were shooting for is this sort of trade-off of what we can do today. So there will be more improvements coming around the caching layer. We want to build in a distributed cache into basically these same processes. But this is and should be at least an easy way to make it easier to run Loki in HA in horizontally scalable way without needing. So, if you were outside of Kubernetes, you just need these 2 binaries and they can share the same config file. Yeah. Anyway, it was a good demo until I broke it, but.
Do we have any benchmark, Ed? Like how is compared to the HA one, the one we run inside?
What was the question, Kavi? Sorry.
No, asking like, is there any like benchmark we tried with this running like read and write target compared to the one we run as as different components basically?
So we've done just a bit of head-to-head. So in order to sort of make sure that the performance was acceptable, I don't have a whole lot for like real detailed benchmarks. So in the same cluster when we were querying, but it was with a smaller set of queryers, probably 3, I think at the time. The performance was the same or very, very similar. I can say depending on the types of queries, cache can play a huge game in certain types of queries, especially with slowly writing streams that have full range 2-hour chunks. You end up using the same chunk multiple times in separate queries. So having a centralized cache that can share that same info saves you from a lot of round trips. Other things too that exist. Go ahead, Owen. Sorry.
I was going to say we could also just run with like a set of memcache in the same way that we do in the distributed mode. In this mode, the scalable single binary mode, it's just like you'd be running another thing, which is kind of against the purpose of this. Yeah. Although it's totally up to operator's choice there.
Yeah, and that's a good point because the config is the same. We're keeping the same. So there's another part that I didn't mention is there's an effort as part of this is to reduce the config complexity as well, to stop having to fill out sort of redundant configs. And so that work will also make it a little bit easier to run this. But the same config will apply. So you could take this, like Owen just said, and introduce memcache in here and add the config to tell Loki to use a centralized memcache. So you can definitely do that as well. Just around now. I don't know how big the autoscaler will let us go in this environment.
So are you just trying to run like you're trying to get the screenshot for the the community
For the
call?
YouTube
Yeah, you
Nice.
just add the YouTube optimizer these days. Is that what we're going for? We got 40. What's the concurrency on it? 16.
No, oh, did I leave him at 16? I might have.
That's gonna hurt you regardless because it's just gonna overschedule the CPU cores.
Probably, yeah.
But
the best part about these is that I don't think they have any CPU. No, they have CPU limits on them. So we just go ahead and be the noisiest neighbors that we can be. All right, I'm gonna stop sharing because I think you're up, Kavi, right?
Yeah.
So I'm gonna let Kavi share, and Kavi's gonna tell us while these nodes boot and I figure out how to fudge the screenshot. He's gonna tell us the work that he did on using log CLI without Loki to be like Loki.
Yep. So can everyone see my screen?
I can.
So I don't have a PowerPoint presentation. So yeah. So yeah, it's basically like yeah, like it said, it's one of the hackathon project we did like a couple of months back, and just a note, it's in the same state. So I haven't touched after that. So if something breaks, yeah, I don't know, we'll see. So yeah, so the basic idea is we have a LogQL, right? And it's a standard language. And currently, we can use this LogQL only against the Loki servers, right? Because Loki servers are the one who fetches this log lines from the chunks for us and do the parsing and stuff, apply LogQL on top of it, right? But if you think about it, if you already have the files locally, you don't need Loki servers, right? So because all the log files you have, it's in a text files or like some file in your local, and you want to do just a LogQL on top of it, currently you can't, basically. So that's what that's the idea, basically. And why we have to do that? There are some various reasons, right? Like I said, LogQL is a standalone language, right? And you can do like way more things for processing logs. And yeah, you don't need to have a Loki server. Why should you have a Loki server just to do LogQL on it? That's yeah, that's a kind of like a motivation behind it. Plus, yeah, also learning LogQL, right? So you see Loki and you want to try some LogQL queries. You don't have to set up all these big Loki servers and yeah, so that you can just to learn LogQL, basically. Plus, it also, the another point is like in the community channel, we often get asked a lot of questions about LogQL, and usually the conversation goes like some people ask the question and we just go and try, and we kind of like try to guess because it's always difficult to have the exact log entries and or exact to simulate this exact thing, right, with our infrastructure. So we try to guess, and if it goes wrong, they come back, they try this query, and they come back again. The problem here is like the people who is asking this question, they already have the log files, right? They have this log entry lines, but still they couldn't able to like quickly validate some piece of this LogQL just because they need to send it to Loki servers and it has to validate it, right? So yeah, that's kind of some of the motivations behind it of this. So yeah, that's basically my presentation here, and let's see the demo. I don't, did you even ask like, is it even visible?
That's good. Also, I like your presentation. I like it better than mine.
Okay, can you guys see my terminal here?
Yep.
Okay, cool. So yeah, I have some log files here. First thing is taken from Loki. I just quickly take this from our infrastructure and also from my internet, actually. So forgive me if it doesn't make much sense. So yeah, this is our own Loki query, Loki logs. And also I have some Nginx log. And also I have Nginx JSON log. Yeah, basically to try out these things. Okay, so the only extra thing we added, and yeah, we are adding this in a log CLI. Probably, yeah, everyone knows log CLI. It's a CLI tool where you can, query Loki servers basically, like for the, you can apply LogQL via log CLI. So we have log CLI, and only extra thing we added for this feature is this flag today, right? So what this does is, instead of sending a request to the Loki servers to fetch the logs, it try to take the log entries from the standard input basically. So usually you do something like this, loki.log, and you pipe to it, and then you make a query basically. So yeah, before trying out the query, I have to mention a couple of points here, right? So because if you use Loki and LogQL, probably know like labels and label selector plays a major role there, right? Whenever we scrape logs, we add certain labels. But when we talk about text files from the standard input or like from the local files, there are no labels, right? So currently we kind of like a fake it, because LogQL itself kind of like compliance as a syntactical error if there is no log selector. But we are working to remove that kind of like a weird dependency there. So basically I'm gonna type this foo equal to bar, but it has no meaning here. That's why I explained it before. So this is just to fake we giving some labels selector to the LogQL, but it has no meaning currently in our scenario, right? So let's try this one. So yeah, so this should display all the logs in the log file because we haven't queried anything, right? So let's maybe start simple. Let's try some simple line matcher maybe. So let's say level equal to error. I don't know. So yeah, so there are like a couple of lines. We have error here, right? So this is a simple line matcher, and we can also do the same thing with label matcher, right? Since our logs are log font, so we can use the log font parser. Let's see, so yeah, and then we can do the same thing. Now, if you see, after doing this log font, everything is a label now, right? So yeah, so we can use everything as a label here. So the last query, what we did, we can also do like this, all right? It should be the same, yeah. So you have a couple of error long lines, right? So let's maybe try something else. What else we can do? Yeah, maybe we can try the line format maybe. So we can also combine it. For example, let's try to print only, I don't know, message. Oops. So maybe where it is coming from, the caller. So it prints the caller and the message. Okay, we also have this path and something else error. Let's try to print that also. Yeah, this is basically a combination of any parser plus a label matcher and a line formatter, right? Maybe let's try something else. Maybe let's try JSON. I don't know.
Cool. So it works for all of LogQL.
Yeah. Only, I mean, yeah, only for log queries. Metric queries is a bit weird. It kind of works, but yeah, we are trying to take it out of scope for now, because when we say metric queries, we need timestamp, right? Apart from the labels. So it's difficult to assign timestamp to this log entries coming from standard input.
I see.
Yeah. I think I tried like few methods there, like assigning some ordering basically, but yeah. So yeah, first thing we're gonna make it work completely for log queries, and then yeah, we'll park metric queries and we'll pick it up later. Basically, that's the idea.
Very cool. I haven't seen this before, so this is exciting for me.
Yeah. So let's try if we have other parts that's working. JSON. Let's see if it even works first. I haven't tried it with JSON actually. And something on the logs. Jason. Okay, so now these things should be labels. I don't know. Let's try maybe only 3 or 4. I don't know, where response equal to 3 or 4. Yep, it's a 3 or 4.
Nice.
We should be able to chain. I think so. Let's see if this also works. Yep. We have 3 log entries for that particular IP. Let's try also the pattern parser, which is kind of interesting. But I think pattern parser will be nicer with the normal Nginx log, I think. So let's see if it works first. This is normal Nginx log without any JSON or something. So here there are 2 options here, right? We can either use regex or pattern. Let's try pattern parser here. I don't know. Let's try to extract the IP, maybe the first one. And just to be sure. Okay. So can you guys see me, right?
Yep.
Okay. This should be fine. See if we can match that. There we go. Oh, I think it works. So this is IP, same IP. Let's try that. It's also with.
Nice.
Cool. So yeah, I think it works with. I think it should. I mean, because there is no magic in this stdin flag. It's just a simple. It does everything like before, like a local wise. The only thing is like, yeah, I don't make a network calls, and it takes input from stdin basically. So ideally, it should work for all the log queries. So technically,
yeah. This is really fun. I can think of a number of use cases that I would use this for, just working with files that I have on disk, where maybe they're big JSON files and I only want to see part of them. Maybe it's a bit easier than JQ to work with. The metric query problem is an interesting one, because I could think of use cases where instant queries, like I want to look through a log file, get the count of some values and like display it. Like range queries are a bit weird because you're going to get a bunch of, range intervals output, and I'm not sure how to use those, but we'd have to figure out somehow how to, shoehorn in some timestamp parsing to make it effective for some of the things. But I don't know, some of the counts, and it's possible. But anyway, for now, we're working on getting, just say Kavi's working on making it useful for, text file filtering and reformatting, and give you a chance to play around with your logql locally. And I think it's pretty slick, Kavi. Nice work, man.
Yeah, cool. I think that, I don't know if people notice, there are like a couple of bugs. They're like, if you see while printing the log, it will print the direction. I think if you try to reverse it, I think it will panic or something, I guess. I just found this bug.
Feature, not a bug, Kavi.
I think I introduced this bug when I changed this heap iterator. It was not happening during a hackathon.
Yeah, we're also trying to figure out what to do about the label selector, because you have to have a label selector for the PromQL or LogQL validation to pass. But like Kavi said, it doesn't mean anything because there aren't any labels really assigned.
Yeah, I mean, there are a couple of options here, right? So I think we already discussed it a little bit. Like if we decide to take different files, we can have a file name as a label, for example. So one option.
Yeah.
But you're right. I think it should work without label matcher for sure, because that should be definitely an optional, I guess.
Yeah. So, while Kavi was working, I managed to get like 150 gigabytes a second worth of query. Should have been made up a bigger number, terabyte a second.
Nice.
No, I actually reverted it back, so we're not running so many nodes. But I actually did go look up the talk I'm talking about. It's linked in the community call notes. Fabian Staber gave this at FOSDEM 2017 about the tool that he wrote called Grok Exporter, where he went into some really fascinating detail around how pulling files and different operating systems and options. And that was a huge help to me at the time for trying to figure out how to manage this prompt tail. I ended up taking the easy way out and just polling because it's reliable and it works, and it's been working well for us. Actually, PromptTail does use FS Notify to know when files are added and removed, but we don't use it for knowing when events are added to a file. But just closing the loop on that one for y'all. That's it. That's all we got on the agenda.
Cool.
Talk about.
I think I have to run. Maybe I'll see you guys tomorrow.
The run. Bye, Kavi.
Take care.
Thanks for the demo, man. It was awesome.
No problem. See you guys.
All right. Well, then I think that does it for this month's installment of the Loki community call.
Yeah, big one today. Thanks,
If you
everyone.
stuck with us this long on YouTube, make sure you hit that like button and subscribe. I waited to the end this time to shell it out. Go downvote the Tempo community call. No, don't do that, actually.
Those are some tactics.
Oh.
That's it. That's it. Thanks, everybody. We'll see you next month.
Take care.
See you at Observability Con before then.
Yeah.